For this week, we are going to focus on about 6 different things. Be looking at data acquisition and wrangling. Last week we talked about how you frame data science problems, but obviously at the center of data science problems is data. Now we want to look a little more into data acquisition and wrangling. We want to look at data sources and acquisition strategies. Of course, there's a notebook demo, where we'll be importing data. We'll look at wrangling and data structuring, and then some practice and mastery check. You're going to see that at the end of the class. Again, like I mentioned previously, you need to begin to think about a project that you're going to be presenting as your capstone, where you pull together all of these skills, you would learn all through the course of this course. So data acquisition and wrangling. So the first thing this week, the goal will be to learn how data enters a project, right? How do we put that data into the project? Typically, it could come in as files, or it could be some kind of URL that you're using. It could be JSON type data or APIs, right? Application programming interface, where you're pulling data. So one way to describe APIs would be like if you are in a kitchen, you have servers that come in there to come and take your order. But you have a back office or back side of the restaurant, and you have the front side where customers are sitting. All of the cooking is done in the back side, and all of the eating is done in the front side. But someone has to run between the back side and the front side, right? To collect the food, collect the order from the front side, take it to the back side. Once the back side prepares it, collect the food from the back side and bring it to the front side. And that guy or the lady is called a server, right? That serves the food. Their own job is not to eat the food, it's not to do any other thing, but to make sure that information is communicated back and forth. And that's the role of APIs. So you have a situation where sometimes there might be data, publicly accessible data, say on some Google website, and you're building an app and you want to serve, maybe let's say it's weather data, you want to serve some of that data to your app. You use an API, right? And the API will help pull that data, bring it back, and then do that communication back and forth. And sometimes you might have to scrape pages. A lot of times there are publicly available information in the open space, and there are scraping tools with which you can go scrape some of that data. So the second part is to practice turning raw data into usable tabular structures. Sometimes you really want to turn some of that data into usable tabular structures. Now, typically you have structured and unstructured data, and a third category of data is what you call semi-structured data. JSON, for example, I think JSON should be semi-structured data. Charts that you see online, you have text, sometimes videos and everything, those would be unstructured data. And then you have structured data like things you see in tabular tools like Excel and all of that. That will be structured data. But there are some time you want to curate the data. You want this data in tabular form because they are really easier to work, in most data science, especially manual data science type operation. When you begin to pull in machine learning, AI, and all of that, it gives you flexibility with what kind of data to work with. But typically, you want to, practice turning raw data into usable tabular structures. So the next thing is we want to build a habit of data documentation, ethical acquisition, reproducible wrangling. That is really very important because when you remember, we were talking about data science being a disciplined process, right? So you want to figure out what the best practices are And to do that over and over again so that it becomes a habit, so that in your data acquisition, you're making sure you're acquiring data ethically and in a very reproducible manner. So the final mission for this week is to connect data set sourcing directly to capstone feasibility, right? So, and that has to do with the projects that you will be working on. So some of the learning outcomes we have for this week is to, show you how to read CSV data, which is like your Excel data, and JSON data into Pandas. We saw a bit of that last week. Um, it wasn't specifically CVS and JSON, but we were reading some data into Pandas. But today we're going to see how to read CSV and JSON data into Pandas. We also one of the outcomes will be how to use requests, to retrieve API data, and then we want to explain when data scraping is appropriate and when it is not, you know, just going randomly and scraping data. Sometimes it's appropriate, some other times it's not, might be unethical. We want to apply filtering, grouping, merging, melting, encoding, and feature engineering into our data science process. And then we want to create simple data dictionary and source nodes. So this is our data sources and acquisition strategy. Now, the source you choose determines what questions you can answer, you know. So if, for example, if I'm looking for continuous flow of data and up-to-date data, I probably might not want to use a static data source, right? I could use sources that can be updated fast and easy. So easy to access data may not be the right data. In some cases, useful data must be relevant, it must be trustworthy, it must be sufficiently granular and ethically usable. You see the recurrence, trustworthiness, ethical, those, because data is a really complicated subject. In some jurisdictions, for example, there could be legal ramifications for the type of data you use, and there are clear, guidelines or laws, around the use of data. Now, again, documenting your data origin is part of professional responsibility, not accountability. Not everybody documents their source of data, but it is good professional practice to do so. And when you do your capstone project, there will be a requirement. I consider this a requirement that you document the sources of your data, how the data was acquired, and make it explicit. So common data sources, right? You have a couple of sources which we have mentioned before. It could be through an Excel. Somebody has entered it there, or it's been pulled through some kind of, online form or through some websites, and it's been stored in some Excel or CSV file. It could be through databases. You have all kinds of databases, and that could be the source of your data, or it could be through API, or it could be through a website. There's broad availability for all kinds of things, or it could be, for example, in companies where you use sensors, or in, a lot of mechanical applications where you can use sensors to pull data like temperature data, heat data, pressure data, and all of that. You want to put it together, and then that's your data source. The strength of these CSV files is they are easy to share and inspect. For databases, they are structured, scalable, and queryable. In other words, you have database managers that organize those things, make everything clean. So that part, one of the things I mentioned, that's one of the most difficult aspects of data science, or the part that consumes a lot of time, is actually organizing, cleaning up that data. So if you're using a database, that's less of a problem. For APIs, they are programmatic and repeatable. All you just need to do is, make a call. Once you have access, data can flow back and forth. Web pages, broad availability is just that you want to find out whether the data you're pulling is legal or ethical. And then sensors, they're high frequency operational data. You can just collect them provided your sensors are working. The risk for the CX data is there might be version confusion. There could be manual errors because in the most parts, you know, um, the entry could be manual in some cases, and then there could also be, of course, the data cleaning and management. All of that could be manual, so they are prone to errors. And then for the databases are created by humans and they are managed and protected. So the challenge will be, do you have access and do you have the right permission? Sometimes you can read, but you can't write, So those are some of the concerns. And then for APIs, rate, because when you're doing the API call, sometimes you have to pay, you know, you have to pay to get access to that data. Then authentication, schema changes. If the schema changes, on one end and it's not changed on the other, then you might be pulling gibberish and all of that. So those are some of the risks that exist with the API calls. For the web pages, there could be legal or ethical limits to the use of your data. And then sometimes the fragility with HTML could be there. And for the sensor data, it's about noise. Sometimes it's pulling gibberish. These are automated systems. The volume can be a lot, and then managing it becomes um, an issue. And sometimes there might be time alignment, especially when you're dealing with time series data, which is often the case with sensor data. So data could be literally in different layers. You have the raw data, that's data as obtained from the source, just exactly how it is. For example, API response from a JSON, that could be an example. For intermediate data converted and lightly standardized. At this point, you have massaged the data a little bit, you flattened. An example would be when you flatten a data frame, for example. But this is the cleanest form of data. Its analysis ready is cleaned, documented, transformed for a specific question, right? It's a model table with features and targets. Feature engineering, would mean that you don't put everything there. You look for the specific variables that are most relevant to the question, which means often you have to massage data, remove, things, combine things, right, to get the exact kind of data that helps you answer the particular question you're trying to answer. So this is a checklist of responsible data acquisition. Some of the things you want to ask yourself: do we have permission to use that data? Does it contain personal or sensitive information? Often you want to remove personal and sensitive information, or something sensitive information could be health related data. Often, for example, in the US, you have HIPAA laws that would not allow you to use that kind of data. So those are some of the things you want to check. The data you're trying to use, is it sensitive? Because if sensitive, you use that data, it might end up in a lawsuit, and you could be criminally charged, or you could have civil action, addressed against you, or both. So scraping or API calls allowed by the terms of service. Just because the data is available doesn't mean you can use it for specific. It might have been set up for specific uses and not for other uses. So you want to look at the terms of service of that data, right? Can the data source be cited and reproduced? That could be an important consideration. What populations or events might be missing? Because that's a very important thing. If certain, and it speaks to context, right? If you have certain data, but in full context, there are other data that you should have had. You can analyze the data that you have, reach some conclusion, but that conclusion doesn't tell the whole story. So you want to ask yourself, when you have data, do I have the full context, right? And that's where what populations or events may be missing. That's where you have to look at it. And if it's missing and you can get additional data somewhere to map to the existing data, then you're more likely to capture the context of the problem. So the other is file path discipline. Often when you're using your Jupyter notebook, right, and you're trying to pull data, sometimes and you're not using a clear project, structure, you might keep on hitting errors, right? So you have to organize everything. So let's say I'm in a data folder, right? I want to be able to store some at raw, some as intermediate, processed, and all of that, right? And you have to make sure you know what you're doing with how you save everything, so that just by looking at this, I can tell, okay, these three different data types are inside a folder called data. So you have to be clear about your project structure. So, and that helps. That's a display of file path discipline, because once your file path is not clear or there's no structure to it, sometimes finding your data can create problems. Notebooks outputs, maybe you have a particular place where all of your outputs go. This is your data. You have a place for your notebooks, and then you have a place for your outputs. So think of it, when you think about the hierarchy for this, you might have a project, and under it there are three folders. There is data, there is notebooks, and then there is output. And under data, you have raw data, intermediate data, processed data. And then this is your notebook, and then your outputs, you put them in a folder called outputs. So be organized like that. The next thing is to avoid hard-coded absolute paths when sharing notebooks. You don't want to do that. Save transform data only after documenting what changed, right? Documentation, documentation, documentation. It even gets more critical if you're working with a team, because they could just see that an update has been made, data has been transformed, but nobody knows why you have done it. So being able to explain what's going on, leave comments and all of that is really very important. And then make the notebook runnable by another person. Again, especially when you're working in teams. So this is importing data, and we're going to go to the Jupyter Lab to run some of this, but I'll just give you a quick, in case you're working on something and you want to implement something. So this is an example of me trying to read how you can read an SSV file that is somewhere on the internet, right? This is coming from, I believe this is coming from GitHub, and then import pandas as PD URL equals to, and then you put that in quotation marks, and that's how you pull that CSV file that is there online. So the next thing you say Titanic, that's what you want to name it inside your system. And then pd.read underscore CSV. And then this is your URL you just put in here. Just putting your URL. One way to do this is to copy all of this and put, but it doesn't really look clean. That's why you equate it to this variable and then put the variable inside here. Essentially, it's pulling this, right? And it's reading it. And then with .head, you can see maybe the first 5 rows in that in the Excel sheet. And then with info, you can have a general idea of everything, how everything within that CSV file. So this will be the piece of code that you can use to read from an SSV file, right? That's online. So this is how you read a JSON file, for example. Same thing, you look for a JSON, that's your JSON URL, almost the same thing we have. And then you want to pull certain things from that JSON file, right? You want to pull the ID, the name, and the username and email .head, and it will just give you those information that you're looking for. And then this is an API request pattern. This is essentially what it will look like. So this is your package request. You're also importing pandas as PD. Your response, this is a .get, request.get helps you pull, you know, and this is your status code. Your data will be equals to the response that you get. .json repo is equals to PD data frame. You list what it is that you're looking for and this, and then it begins to do the API call. Now, what happens if API is unavailable? These are reliability issues you need to think about when you're building your model, because sometimes, there is a downtime. What do you do? What status codes indicate success or failure? Does the schema change over time? Schema, essentially how the data is organized. Is authentication required? Sometimes it is. Should the raw response be archived for reproducibility? Those are the kind of things you need to think about. Scrapping should respect terms of service when we are now dealing with data scrapping, which is you just scraping data off the internet for ethical boundaries. You need to maintain ethical boundaries when you use data. In other words, you need to use data responsibly. Scraping should respect terms of service, rate limits, robots.txt, and data privacy. So HTML structure can change. So scraping code is fragile. If the HTML structure fails, then you have a problem, with your code. Scrape only what is necessary and do not overload servers, just because sometimes you're not the only one scraping. You want to just take what's necessary. When possible, prefer official APIs or downloadable data sites. So conceptual model, Beautiful Soul, one of those tools for scraping. So requests, right? Retrieves the data content. That's essentially what requests do. It retrieves Beautiful Soul, right? So Beautiful Soul passes HTML, and then selectors identify tags, classes, IDs, and tables. And this is best, when we begin to look at examples of how this is done. The output must still be cleaned and validated before analysis. So if you get all of this data, you still have to clean it. So all you have done is just pulled the request. So typically to build the web scrapper, right? Request is what you use. This is a library, specific library that you use to download raw HTML data from websites. And Beautiful Soup, I think it's Beautiful Soup 4 right now, is that library that you use to pass and extract specific structured elements from that HTML. So, and if you go online, you see a whole number of tutorials, a lot of tutorials about Beautiful Soup. So this is a basic, Beautiful Soul pattern, right? That's very basic. So you first of all import requests, and then you also import Beautiful Soul, and this is a specific what do you call it, design pattern. You use your standard request. This is supposed to help you fetch raw HTML, HTML data, and your HTML request get. So for example, I want to get web data from a website called example.com, the text, and then I'm considering soup to be my Beautiful Soup. I want to pass through it. So find, hi, get, and then you print out your title, whatever you pull from here, because you're using your soup and you're using a method called find, and you want to pull H1 tags, you get it, and then you strip, right? And you get all of that. And again, if you go online, you're going to see different beautiful soul design patterns that you can use to pull data depending on what you are looking to pull. So the next will be wrangling and data structuring, right? So in wrangling and data structuring, we have select, and these are some of the tools that you can use to select and filter. And we're going to see that once you go into your Jupyter notebook. You can see how Pandas tools like lock, Boolean masks, they are used to focus on relevant records. You want to pull specific records by, in some cases, you want to aggregate data or group data, and this is what you use, group by. Aggregate, you summarize things by category. I think in week 1 we did do that, where we were looking at data, sales data from different regions. We had different things, say for example, in the northern region, in the south region, but then to aggregate it, right, all we just used was group by, and then we said something like region, and it will keep all of the regions. There were 4 regions, even though there were different entries that had different regions. Sometimes the northern region was implicated maybe 4 times, but when you use group by, it will aggregate all 4 of them into one total. You can also use Pandas tools like join and merge or concatenate, to combine related data. You can reshape, melt, or use pivot table, which are tools to change data layout, how it's organized. You can encode, using Pandas tools like get dummies to convert categories from models, and then feature engineering, create new columns, create meaningful signal. That's what new columns, for example, does. So in real, wrangling is actually analytical thinking, because every transformation that you make encodes some kind of assumption, right? Filtering can exclude important populations, so you need to think through. Once you're wrangling, you're essentially including, excluding, combining, and all of that. So you have to be really careful about what you're doing. Sometimes your grouping changes, the way you group things, right? Can result in changes in the unit of analysis. Joining can duplicate or drop records. Feature engineering can improve analysis or accidentally introduce leakages. So in feature engineering, you may have 10 different variables, but maybe the most important variables are 4 of them. You have to figure out how to determine what the best 4 are and focus on that. So let's say 4 of those variables will give you the exact context that you need, but instead of keeping it at 4, you now exclude one additional one and it's just 3. Now you don't have the full context. So it really requires a lot of analytical thinking. So when you go doing your data wrangling, you have to be it's a lot of analytical thinking to decide what to pick up, what to accept. And again, sometimes experience can be very helpful, lends to this helpfully. So this is an example code for grouping and aggregating. Now we're looking at this probably Titanic data. We're looking at the survival and average age by passengers. So we get our data, which is Titanic, and then we want to say group by class, dot aggregate. So you want to group them by class and then aggregate everything. And that's the kind of code you have here. You're looking at your survival rate and average age. So all of these could be how you group by, and this is best looked at when you go into your you know into your Python code. You will see clearly what this returns, but that's the piece of code that you can look at. And this is a case of feature engineering, where the goal of this code is to create a family size feature. and SIB, SP, siblings, spouses abroad, and the patch is the parents and the children abroad. So that's how this data is aggregated, and it's also from the Titanic data. So you want to find out here, when you have these things in square columns, you are trying to pull out the family size, so you are saying that your family size is equals to your Titanic, and then you go pull siblings and spouses are aboard. That's what that data in the Titanic data represents, plus the Titanic patch, which is parents and children abroad. So you're trying to combine the siblings and the parents, children abroad plus one. So essentially, you're going to get this dot head. So you've put all of these together, and you just want about 5 of the column of the rows to see what happens after you've put all of these together. So the other part of things that we might encounter is one-hot encoding, right? And this has to do with categorical data into, we essentially going converting categorical passenger class into dummy variables. And if you don't understand this clearly, when we get to the other side, you're also going to see it. So for example, I could have different categories, 3 different categories, say nursery, primary, secondary, university. I can label each of them. If my target is nursery, all the other ones will be 000, and then the positive one will be 1. Those kind of things you can convert. You can also convert, in this particular case, categorical class into dummy variables. So let's look at this class dummies. This is the dummy that I'm creating. Is equals to PD. We are going into the data frame dot get dummies, right? I'm using get dummies is the method, right? And we're trying to pull the class, and the prefix will be class. I'm trying to concatenate, in other words, pull together Titanic class dummies, which is this, and axis 1, Titanic model dot filter, and I filter that, and then we get our head. Again, would just go quickly into our Excel sheet to our Python code to show you the example. So if you don't understand all of that, it will be better shown than just told. But I just wanted to begin to introduce you to the concept before we go to our Jupyter notebook, the Excel code, the Python code. So data dictionary standard. So a lot of times you have variables which are the column names exactly as used, meaning will be plain language definition of what it is that you're doing. When we say type, it's listing whether it's numeric, it's categorical, it's text, data, or Boolean. An example, a representative value, and then notes, missingness, transformations. And so this is a standard data dictionary, right? When you say variable, this is what you're trying, the description of variable, you say meaning, that is referring to a plain language definition. And we're also going to see all of that when we do actual demonstrations. And I think that's mostly where we are. The rest of this will be, we're going to in-class labs now so that you can see. And then the rest will be some of the things that we will come back to later. So I'm going to drop this, and then I will pull up. Yeah. So we're still sharing. Let me stop sharing and share again. No, I'm going to stop sharing this. That's not what I want to share. And then I'm going to go share. So this is our notebook. So we're going to week 2. So uh, that will be a continuation of what we just talked about. So our key learning objective, right, with our Jupyter Notebook slides will be identify common data sources and file formats. We've talked about that a little bit here. Then we're going to load CSV files, but this will be the practical aspect of what we're talking about, your JSON, your semi-structured data into Pandas. We want to simulate API style data acquisition using JSON records. And then we want to extract tables from HTML safely using local examples. We want to apply core wrangling operations like select, filter, derive, group, merge, and reshape. And then we want to create a basic data dictionary, part of what I just showed us a moment ago. And then we want to document data provenance, assumptions, and limitations. Now, so this is your typical data acquisition workflow where you define the data that is needed, you identify possible sources of that data. Now we're talking about, how we get our data and organize, curate that data. We want to verify access permissions and ethical constraints. We want to make sure we do that as we acquire our data. We want to import data into a controlled environment, right? Some kind of storage where we would pull it from. We want to inspect the structure, the types, missingness, if there are things that are missing, even the data quality, starting probably with our exploratory data analysis. We want to transform it into an analysis ready form. If there are things we need to remove, if there are things we need to merge, or things we need to add, that's so that eventually we have an analysis ready form of that data. And then we want to document the sources, the fields, and the cleaning steps that we're taking, and some of the limitations that we encountered. And then we want to make sure there's reproducibility, right? So as in the past, this is what we have, our key packages that we've installed. We get our PD. We want to set option, display the maximum columns. We want it to display only up to a maximum of 50 columns. And that's for our columns, and for our width, 120 rows, right? Random state 42, NP random seed. So we want to randomize some of this data, and then I'm going to print out to check whether my installation and everything is correct. And then it's running, and then everything is correct. So I want to read. So we use a local CSV string to keep this notebook reproducible without internet access. So this is what I have, the data that we have here, right? We want to be able to read that data using, remember, .read_CSV. And then we just want to read past that data with the dates and everything. So if I run this, this is what I get. All right. So this is something we are starting with. So to figure out the general analytics of this data, we can just say orders. Our data is called, that's the name of our data, but if we include this method, it gives us a summary analysis of what this data is all about. So that's where you run here, and then that's what you get. It's order ID, customer ID. This is the customer ID. It shows you 1, 2, 3, 4, 5, 6. Order ID 1, 2, 3, 4, 5, 6, starting from 0. Region, this north, south, east. There are 6 regions, blah, blah, blah. Unit price, unit price, there are 6 of them. And these are the various data types, as you can see. The only thing that is order date, where's my order date? This is the order dates, and it shows it. That's the only different data type here. And then you have your object data and your integers, right? So that's how everything is set up. But let's assume we are trying to pull a JSON data type. This is what you use. Customers_JSON is equals to square brackets, open square brackets. Notice curly braces here, notice the column and almost like, a dictionary. That's what it is. Customer name is this, industry is this, employee is this. So that's one set of data. And then you do the same thing with this. This is the customer ID. This is the customer name. And then this is the industry the customer is. And then this is the number of employees they have. Then comma, you do the same thing. So I can add in more and more data lines here, right? And then after that, I've gotten my, I want to now, this is the JSON form of that data, but I want to convert it into something I can put in a data frame. So I create a new variable will be equals to PD, which is your data frame, your PD. And when I say PD, come up here, which is your pandas, right? And then using your pandas, I want to create a data frame, right? Which is my method, pandas.dataframe, right? And I want to pull all of this data in here and create some kind of data frame. So if I run that, that's how you create this data frame. And you can see it, right? For the customer ID with C001, the customer name is Apex Engineering, the industry is manufacturing, and the number of his employees is this. And you do that for all the other ones. So if I wanted more, I can copy this and then change things about the companies and I'll get. So this is me trying to use an API, right? I start with my API response, status, success, source, simulated internal service, and these are the records that I'm looking to pull. I said assert API response status is equals to success, products is equals to PD, and that's where I'm converting this into PD data frame. I'm pulling that response, which is this, in alongside the records, right? And that's how I get this. So this is what I have here. And always notice that pandas.dataframe is how you eventually pull it into a data frame. So responsible web scraping with local HTML. You're trying to pull something here, right? From BS4, right? Import Beautiful Soul. This is you trying to import Beautiful Soul because you need Beautiful Soul to do what you have to do. If you remember, this is, in this particular case, we are trying to pull from this HTML. The HTML, the things we need from the HTML is the table, training, duration hour. So this is the code I'm pulling directly, the HTML. And then I put that here. This is your soup, essentially. And then that's your pass. I think this was in the design pattern that I showed us before. And then this is the rows. We're pulling from tr in soup.select. And then your training will be this. You pull all of this, and then when you run it, we'll get this, right? So core wrangling operations converts raw data into analytics ready data. You've gotten all of your data, and at this point, what you're trying to do is to convert it into data that is really available, right? So you have your orders, which is your revenue is equals to units. We already have our orders there, but what we are trying to do right now is to pull revenue and add revenue. We had all of these before, we want to add revenue. So you ask yourself, what is it about revenue? My revenue is going to be my number of units multiplied by the price. So if I multiply both of those, that's how I get my revenue. So that's what I'm creating here. So essentially what I'm doing is I'm multiplying this times this will give me this times this will give me this times this, and that's what this code is about. And then we print out our orders, which is everything. So this is what we had before. We didn't have revenue, but that's how you add revenue. Simply, the square brackets, open and close. You put in what it is you want to create, and then either multiply, add, subtract one column from the other, and then it gives you what it is, and it pulls it out here. Look at another one here, right? High revenue orders is equals to, that's when you are doing filtering now. So we're trying to filter out orders above a certain threshold. And what is it that we are trying to filter out now? Just watch this. High revenue orders is orders.log, so you have orders in quote revenue. So we're looking for any revenue greater than or equal to 500. Where's our revenue here? We're looking for only revenue greater than or equal to, and then we say dot copy, so that it essentially removes any record, right, that is greater than, retains only records that are greater than or equals to 500. So you can see 480 is not here. It's no longer here because 480 is less than 500. So everything that is greater than or equal to 500 was replicated. 450 is gone. 480 is gone. So what you have is essentially this, and that's what your .log helps you do, right? So essentially we are saying any order, the order in terms of the revenue that is greater than or equals to this dot copy, that's what we have here. So in other words, you are literally, here, all of this is your general orders, but now you're looking at your high value orders. So when I'm working this right now, if I want to do some analysis around high value orders, I'm going to use this. If I'm looking for everything, all the orders, I'm going to use this. So I can create all kinds of tables, right, and store them here. So this is a case of group and summarize. So I'm trying to do something around the region summary. Yeah, I said orders. We already have the orders is the main data that we have, the main data set that we have. But that order, I want to group by region. So I want everything here. Where's the original order? This is our regions. We have north. North is here again. We have south. South is here again. We have east and west. So I want to group north together. I want to group south together. And then that's what you use. Where is it at? Group by to do dot aggregate. So I want to group them together and then aggregate them, which is total revenue is equals to revenue, and then the sum, and then the unit and the sum, and then the ID and the count. Then I sort those values too, total revenue, and I want to do it in not ascending order, but in descending order. So which is what is happening here, right? So each of this, I've put the two knots together right now, put the two starts together, and I have the total revenue, which is what they're asking here. I have summed it, total units. I've summed the units, and then the total orders, I have counted all of the orders. So there are two here, and then I have sorted it in not ascending order, but in descending order from largest to smallest. That's the total revenue. That's what I'm descending. So another thing, so each of these, are different. So if I want to do something around region summary, I can use this table. If I want to do something about high value orders, I can use this table. So you're just setting up all of these tables that you can come back to use later, right? So then I'm creating another table that I will call enriched orders or orders enriched, right? So I'm taking my original table and I'm merging a few things. Customers on customer ID, how I want to merge it to the left. I want to turn on customer, that's my focus. Then I also want to merge products, turn products on, and then how I want to merge it to the left. So if you go look at this, all of a sudden, you want to use the customer ID, you know, and then you're merging. So you're creating additional, let's go back so you can see the original orders. This is the original orders, order ID, customer ID, dates, ID, region, blah, blah, blah. See how things have changed now all of a sudden. You know, you've added more columns to it just by using this. So you can also reshape revenue by region and product, and that's where you use your pivots. You go from your orders enriched dot pivot table, and then you tell it, if you've done pivot tables in Excel, this would resonate, you know, and you've told it what your index is, what the product is, and you want to, you know, organize it around region, but by product, you know, revenue. Then you want to aggregate the function and all of that. See what you're doing here essentially. You're putting all of this, but you're aggregating it around product, and these are the products. So you can do the same thing here, you know, where you're using a function called melt. So usually it changes the dimension of the data, wide pivot back to long format. So same thing, but now you're reshaping it to turn it the other way around, right? That's what you use melt usually for, you know. So professional analysts build quick checks into their workflow. That's another thing. You know, some of the checks is no missing customer names, order enriched, and then you're checking if that's where this method not any. In other words, you want to make sure there is no any. Any is not applicable, and then you want to check through using this method to check through all of that to make sure there are no customer. Same thing with revenue. You want to make sure there are no revenue, you know, that is, make sure all the revenue is greater than or equals to 0, you know. So all of this is what you use, so that once you use it to run a check, it will go through the data and check to see whether all of these are true. And then this is, we're talking about data dictionary. A data dictionary makes your work understandable and reusable. So order enriched dot column, you know, this is your description and all of that. So when you run that, this is what you get. You know, which is what I was describing in the other ones. You know all of your variables, you know your variable types, and you have a description of what each of that is, so that when someone sees that data and sees your data dictionary, they can easily tell what each variable is about. And this is how you create it essentially. This is your description for each of them, you know, the data type for the string for data type in order. So it's running through, it's like a loop running through the entire order enriched file to determine the data types, right? And then you put their description here. And how you separate it is just comma, string, comma, string, comma, string, comma, and then until you get to, and that's how it lists all of this. So the assignment will be to submit a notebook that imports at least one data set, performs at least 3 wrangling operations, create one derived variable, merges or reshapes data, performs validation checks, and includes a data dictionary. You have to explain your source limitations and ethical considerations. So this will be important, and that will be part of the work I would expect you to do. So I think that's where we will stop for this week, and we'll catch up with you next week.